have an exam after 2 months related to light. Doing this revision at that point of time will not help you. So worst case scenario, you can still rewatch the class that you did last week and spend 2 hours of watching it and going through the step 1 until 10, and then it will get you back to level 9. All right, it will get you back to level 9. Just 2 hours, you'll get you back to level 9, because I think we have already proven this. Every class after 2 hours, you will from starting at maybe 1, and every class after 2 hours, you get to level 9 or even near to level 9, or 8 or 7, or even some of you 10. And there is something that you can be assured of, right? Okay, so let's start today on the new chapter. This new chapter is a bit difficult because the level is a year 10 level. I think most of you are not year 10. Year 10 is Form 4 for Malaysia. But let's try. Let's see whether you are able to go from 1 to 9, right? After 2 hours. So let's, as usual, let's jot down our start time. I believe everyone can see my screen, right? Just to make sure. Just to make sure. Can I have a show of hand just to make sure that everyone can see my screen? Yes. Okay. Now, start time is 8:32. We will start with this chapter called Gravitation. The name itself is telling you that we are going to learn some laws. Okay, Kevin just joined. All right. Hi, Kevin. So we just started this. Yes, today's topic is about gravitation. Gravitation is about satellite. It's about Newton's law. It's about Kepler's law, and the gravitational accelerations. So let's start with step 1. Step 1 is create drawers. We have 5 drawers. What are those drawers? Newton's law, drawer number 1. Gravitational acceleration, 2. Kepler's law, 3. Man-made satellites, 4. Escape velocity, 5. So there are 5 drawers. And I created this very short story. Very short story to help you to, let me remove this so that you will not be confused. Which one to focus? Right here, right? Whoever who was confused just now, I was reading from here, right? So the story that I'm helping you to remember drawers in sequence, the 5 drawers in sequence, is this. If you have a pen and paper, then you write it down, or if you prefer it to write it down in your digital note, whether it's in your phone or whether it's in the laptop, you can write this down. It's a very simple story, but it's going to be very helpful if you write it down, because you're going to take this as a reference along this step 1 until step 10, right? So you can imagine somebody called Newton using a very strong gravity to pull Kelly into a man-made lake. Okay, a lake that is man-made, not a natural lake. And then she escaped, right? So you can imagine Newton using strong gravity to pull Kelly into a man-made lake, and she escaped. So Newton is illustrating drawer, is pointing to drawer number 1, Newton law, using strong gravity. So you can imagine Newton is using that strong gravity, and that gravity is pointing to drawer number 2, gravitational acceleration. Pull who? Pull a girl named Kelly. Right? If I put Kepler's, I think this is not a common name, so it's harder to remember. You can put your friend's name, or whichever name that is more relevant to you. For my case, I put it as Kelly, right, to reflect Kepler's. Then now drawer number 4 is man-made lake, which is man-made satellites. And then she escaped. Escape means it's pointing to escape velocity. or she escaped fast, or the fast can be representing the velocity. So Newton using strong gravity to pull Kelly into this man-made lake, and she escaped. Let me show you the video. Let me show you the video quickly here. So let's hope that this video is able to help you to remember this main story. I did not put it here. Okay, maybe I put it over here. Okay, give me a moment. I'll show you the story. Okay, it's here.
Form 4, Chapter 3. Gravitation. Newton, using strong gravity, pull Kelly into man-made lake. She'll escape.
All right. The AI video looks like it is pushing rather than pulling, but it's okay. I think you get the idea, right? So you can picture that animations now. Imagine this Newton, this man is trying to pull Kelly into this man-made lake using strong gravitational force, and then she escaped, right? So that is to help you to remember the 5 drawers, right? So now let's move to step 2, read the keynotes. So as usual, it's usual for all of us here except for Kevin. Kevin, I think this is the second time you are attending the class. So hope that you are able to follow the steps. So for step number 2, how you're going to read it is you read it with the intention that you're going to learn something from this step number 2, not to have a full understanding yet. Because if we have to break it down into the understanding level from 1 to 10, 10 is the highest. That means you understood perfectly. 1 is the lowest. You should be at 1 or 2, the level of 1 or 2, after reading step 2, right? Join us. Okay, let me just click the button. Right. Hi, Jovin. So we just started, and we are in step 2 now, Jovin. Right. If you cannot see the screen, then you let me know. I hope everyone can see the screen and hear me. So I'll continue on step 2. So now your understanding level is about the level of 1 to 2, right? Okay, good. So let's start by reading this. There are quite a few formulas, just to give you a heads up. There are quite a few formulas. So don't force yourself to remember the formula now, because there's no point. You just need to know there is this formula in this drawer, or there is such complicated formula in this drawer, and that's it. You're going to remember the drawer, the formula as we progress from step 1, 2, and to the following more advanced steps, right? So what you need to know is you need to know that there are 5 drawers, and now break it down into each drawer. You have key points. For drawer number 1, you have 4 key points, right? Drawer number 2, you have 3 key points. If you do not understand fully after reading it, it's fine, because you are still in level 2. You are not in level 10 yet. So I'll give you 1 minute. No, I'll give you 2 minutes to read drawer 1 and drawer 2. Right, drawer 1 and drawer 2. 2 minutes. For those who wanted to continue drawer 4 and 3, you can. But I'll give you another 2 minutes later for that 2 drawers. Okay, 25 seconds. Seconds. Right. Okay, now I'll show you until drawer 5. I'll adjust it this way. Right. So another 2 minutes for 3, 4, and 5. 3, 4, and 5, whoever who finish reading it and you have more time, then you can continue reading the drawer 1 and drawer 2 if you want. Let's start now. Drawer 3, 4, and 5. Thirty seconds. Ten seconds. Right? All right. Okay, let me emphasize again. I'm not your physics teacher. I'm facilitating or guiding you on this study method that is having 10 steps. And we study together using this study method. We call it brain drawer. And now we are in step 2. So I'm guiding you from step 1, step 2, and so on and so forth until step 10. Right? And based on the previous experience from most of the students over here also can testify it. At the end of the step 10, your understanding will increase from level 1 as of now to a higher level, much higher level, whether it's 7, 8, or 9, or even 10. Right? So now, let's focus a bit more on step 2. We are having 5 drawers. I hope by now you have some ideas. What are those 5 drawers? At least the name, right? The names are all written over here. Newton's law, drawer number 1. Then you have gravitational acceleration. Kepler's law. This is a man-made satellite. Okay, we can change it to man-made satellite. Man-made satellite. Then you have escape velocity, right? Remember the story, the very short story, the cartoon animation that I showed you just now? That should be able to help you to remember the 5 drawers in sequence. So first you need to know that there are 5 drawers, and you need to know the name of the 5 drawers, right? Now, let's go to drawer number 1. There are 4 key information. You have the definitions. You have the everyday examples. You have this new force called centripetal force. And you have these calculations between the planetary mass and also the time, right? So don't worry about remembering or memorizing this formula. you understand the formula as we go along. So you just need to know there are these four key points over here for this drawer number one, right? Drawer number one, you definitely need to know what is the definitions. And then you need to know some examples. Then there's this new force called centripetal force. If you know what is this centripetal force just by reading these few sentences or these few words, then you are a genius, and that's excellent. If you do not understand yet as of this point, you're fine. Don't worry. Just know that there is a centripetal force that we're going to learn later in step 3, 4, and so on and so forth. Right. Then drawer number 2, you have something related to gravitational. Right. So at the below Earth is having different characteristic, and above Earth is having different characteristic, and that's all you need to know. How and why, we're gonna know it later, right? And this is also depending on the distance. Then how it is going to affect the human growth or human body, how gravitational acceleration, the G, is going to affect. We're going to know it later. Then Kepler's law, you have 3 laws. That's all you need to know. There are 3 laws. If you know what is law 1, 2, first law, second law, third law, then it's excellent. But if you don't, it's fine. Man-made satellite. So how this satellite is being pushed to the atmosphere, right? How this satellite is not falling down into the Earth, right? So this is the things that we are going to know. And there are 2 types of satellite: geostationary and non-geostationary, right? So how Elon Musk launched so many satellites, and Elon Musk satellite are non-geostationary, right? And what is the difference between geo and non-geo, right? And then is escape velocity. If you need to escape from the Earth, what is the velocity that you need to have in order to escape, right? Okay, so that is step 2. And there are these key informations. So let's proceed to step 3. Right, step 3 until step 5, as we know, it requires quite a bit of a reading. So I need you to mentally be prepared. For the one, for example, like Kevin, who came here only the second time, I want you to have this to be mentally prepared. You need to do quite some readings, right? The rest, I'm not worried. I think you know you have this it's expected what you need to do. You know the drill, right? So how am I going to adjust this? Is I'm going to adjust it into left and right document, right? So whenever you read step 3, use step 2 as a reference, because it's being designed in a way that if you realize it is being designed in a way that is similar to step 2. There are 1, 2, 3, 4 points. Also, there are 1, 2, 3, 4 points over here. The only difference is in step 3 is more elaborated, right? So I want you to have this intention. Now your understanding level now is in, let's say, level 2. After reading step 3, drawer 1, your understanding level for drawer 1 should increase from 2 to 3, something higher, right? You should have new information over here that will help you to understand what is the drawer number 1, right? So let's take 1 minute to read drawer number 1, right? Using this as reference. Let's start now. Fifteen seconds. Right. Let me go a little bit slower here. So there are 4 points over here. Right. And there are also 4 points over here. And they are the formula, and they are the formula for these 2 to 3 points. 1, 3, and 4. 1, 3, and 4. Right. And there are extra explanation that is needed over here in these 4 points to explain what was being written in step number 2. So by now, your understanding level, as I say, you should be having the intention to improve it from 2 to 3. And you will indeed improve it to 2 to 3 after reading this part. By now, you should have more understanding about what is this Newton law of gravitations, centripetal forces, right? And also a little bit of a calculation of the planetary mass. If you do not fully understand, now it's fine. This is normal because you are still at level 3. Remember, to have full understanding, you need to be at level 9 or 10. You are still in level 3. At least now, you understood a bit more compared to 10 minutes ago when you were reading step 2. Right? As long as you have this feeling, and then that's fine. Then we'll continue to drawer number 2, doing the same drill. Right? I intentionally left this here for you to read. Okay, if you finish reading step drawer 2 and you have more time and you want to go back to drawer number 1, please do so. Right? So we will have 1 minute for drawer number 2 also. 1, 2, start. Ten seconds. Okay, time's up. That is drawer 2. That is drawer 2. All right. Let me guess how you are feeling now. You are feeling that there are certain formulas that you do not fully understand now. And maybe also certain relationship like this one. Maybe you do not fully understand as of now. But that is fine. Like I say, you are still in level 3. Right? But at least now, I believe after reading this part, your understanding level increased a little bit compared to 10 minutes ago when you were at level 2. Now we are level 2. Now we are in level step 3 when you were in step 2. Sorry. Right? So let's continue the drill for drawer 3. For drawer 3. And let's do it 1 minute now. Twenty seconds. Right, time's up. Right, for Kepler's law, you have 3 laws. How do I remember this? Or how do I understand this? Is you have this planet that is moving in elliptical orbits. They are not circular. That is Kepler's first law. Second law is the nearer you are to the sun, the faster the speed. So number one, they are elliptical. And number two, their speed is different depending on how near you are to the sun, right? So they do not travel at a constant speed, at the same speed. Number three is, this is to inform you the relationship between the period, the orbital period, and also the radius. Orbital period and the radius. Why do you need to know this? In step 4, we will tell you why. Right. Why do you need to know this? Let's continue on drawer 4. And on the right side is the reference. Right. Also, you have four points over here, and you also have 4 points over here. Right. Newton thought experiment, then the formula, then this R plus H rules, and also the type of satellite. Okay, let's do the same drill for 1 minute. We will read drawer 4. Let's start now. Right. Drawer 4, your understanding level should increase from 2 to 3. Right. 3 is still at a very low understanding level. So if you do not fully understand, if you feel that you do not fully understand, that is fine because you're still at level 3. What is level 3? If you have to put it into the perspective of an exam score. So if exam score from 0 to 100, you should be only expecting yourself to get 30%, 30 points now. Right, 30 points is fail, so it's fine if you do not fully understand. Right, so let's continue. Drawer 5 for 1 minute. Ten seconds. Right, that's it, time's up. Now let's do a quick check. Let's do a quick check. Remember when you first read step 2 at about 8:35, you have very little understanding of what it's talking about. Now read again. Read again quickly. You can start now. Read again quickly. Drawer 1 until drawer 5. You should feel that you understand more than when you were at 8:35 a.m. just now. Right? And it took us maybe only 20 minutes. And 20 minutes, by now, you already have more understanding. compared to before. Nothing changed over here. The only thing changed is your understanding increased. I did not change anything over here. The content is still the same. All right, the content is still the same. So now you know that there are 5 drawers, and you know these 5 drawers name, and you also know a bit more of each of the drawer. What is it talking about? What is the content of that first drawer? First drawer is Newton law. You know that there is this definitions, this very weird formula that you're going to learn more detail later. You know that there's this centripetal force. If you know by now what is centripetal force, excellent. If not, it's fine as well. But at least you know there's this centripetal force in this drawer. Then for drawer number 2, you have gravitational acceleration. Right? You have this key information inside this gravitational acceleration. Drawer number 3, you have 3 laws. Kepler's law, you have 3 laws. Right? It's not circular, it's elliptical. It is faster when you're closer to the sun. And there's this link of time and distance. And drawer number 4 is this satellite. Satellite, you have this linear speed, you have the rules, you have to plus the Earth radius plus the height of the satellite when you do the calculations. And then you have 2 types of satellite. Then escape velocity. How do you escape from the Earth? Because every object like Earth, the big mass of any planet, they have this very strong gravitational force that's pulling you back. But how do you escape from it? You need to be fast with this minimum escape velocity to escape. And what is Earth minimum escape velocity? Is 11,200 meters per second. Right? Okay. So let's continue to step 4. Step 4 is to tell you the frequent asked question and also to tell you why this matters. Why do you need to know this? Right? And you should be expecting your understanding increase from level 3 to level 4, right? After reading step number 4. I believe you have 10 questions. Every drawer will have 2 questions. So this is question number 1 for drawer 1. So let's read this in, let's do 2 minutes. 2 minutes. Let's start now. You can read this one. "40 seconds. "20 seconds. "10 seconds. Okay, time's up. These questions, if you realize, is explaining this point, right? On the keynotes, if you see on the right, drawer number 1, point number 1. All right, is explaining this in a very lengthy and detailed manner. Even it is telling you why this formula matters. Why this formula matters. So this is the so what. This part is the answer. Second part is the why you as Xuan or you as Eric or you as Kevin, you need to know this. Why? This is the reason. Right? It's telling you that there is this relationship between the mass and the distance. Right? So now this formula makes more sense now, I think. This very weird formula where, or very strange and new formula where you saw it the first time 30 minutes ago. Now this makes a bit more sense because now you are at level 4 understanding, right? Level 4 of understanding for drawer 1, right? We have one more questions. This is to solidify your understanding of drawer 1 from level 3 to level 4. Okay, so let's continue this question number 2. Intentionally leave this question number 1 open for you to read if you want to read it again and when you have time. Let's do 1 minute for question 2. $25 seconds. $10 seconds. Right. So this is about 0.3 centripetal force and acceleration. By now, your understanding for for drawer number 1 should increase to level 4. It's like playing games. You're leveling up from 3 to 4. But your drawer 2 and the rest are still at 3. What we are trying to do now is to improve it, to increase it from 3 to 4. Right? So by now, we are in step 4. You should have some idea what is this formula about already. And you have some idea what is this new terms called centripetal force. Right? And this centripetal force is the force that helps us to pull not only satellite, the atmosphere. Right? You're going to know it later. Okay? So this centripetal force is a force that is pulling everything into Earth. Right? So let's go to drawer 2, question 3. Let's do 2 minutes. Give you a bit more time. Okay, let's start now. 30 seconds. Twenty seconds. We have a break after the step 4. Total 10 questions. We are in question 3 now. Right. So question 3 is on drawer 2 and is explaining this and also this point 1 and 2. Point 1 and 2. So this is very important for the student who wanted to know more about how to launch the satellite or how satellite is being launched, and there's a calculation that is needed on the forces that is related to the satellite and also the Earth radius. Then this is the start. This is a fundamental, right? Okay, so let's go to question 4 for 1 minute. Let's start now. Same drill. $20 seconds, 20秒。All right, time's up. Now, let's go to drawer 3. And by now, your drawer and drawer 2 should be at the level of 4. Right? So let's do 1 minute for question 5. Let's start now. $10 seconds. This is law 1 and law 2. First law and second law. So obviously, if you map it into step 2, this is the point number 1 and point number 2 in drawer 3. All right. So let's continue on the next one, which is third law. For 1 minute, question 6, start now. $10 seconds. All right. I hope you feel that your understanding now increased to level 4. Level 4 is still below 50%. Right? If you don't, then there's a problem. But I think everyone does feel that way because this is not the first time we run such classes, right? And I think so far everyone is progressing as expected. Well, okay. So now let's go to drawer 4 for question number 7. Right, drawer 4 for question number 7. So you have to also intentionally link to which point is this. Right, I'll let you do the exercise. Let's start now. 1 minute. Twenty seconds. All right, time's up. Right, how do I imagine this? This, for example, this part, question number 7. What does it mean by the object keeps falling around the earth rather than into it? So imagine now you have a ball or a stone, you try to throw it, it will fall into the earth, right? Eventually, the projectile will just, he will just go away from you, but then eventually you'll fall into the earth, fall on the earth, fall on the ground, right? If you throw it harder, that means the velocity is faster. Then you still fall into on the ground, but further. But if you throw it even harder, you still fall into the ground, but it's even further, right? So point A is nearer, point B is further, point C is the furthest. Imagine now you're having this superpower that you can throw this stone so fast that it will just fall, it will just go around the earth, because earth is not flat. Earth is like a sphere, it's circular, right? So what's going to happen if you throw so fast that it is going to just fall, keep falling, but it doesn't fall because earth is not flat, right? So that is what is explaining. But what if you are a Superman that you throw even so fast, faster than the centripetal force of the earth can capture you to be falling around the earth? And that is drawer number 5, the next one. Escape velocity. That is the minimum speed that you need to maintain in order for you to be always falling around the earth. So satellite is always falling around the earth. But if it's faster than the escape velocity, then you are not falling around the earth. You are flying away to the universe, to the galaxy. Right? So now let's continue the same drill. Drawer 8, still in draw question 8, still in drawer 4. Let's start now. To help you to increase from level 3 to level 4. All right, 5 seconds. Time's up. Last drawer before we go for a break. All right. Question 9. I'll adjust it here. Okay. Your reference is on your right. Your left is a step 3. Let's start now for 1 minute. Escape velocity. 10 seconds. Time's up. Last one before we go to a short break. Let's do 1 minute. Let's start now. Ten seconds. Okay, let's do 5 minutes. 5 minutes break. Toilet break or water break. Okay, I'll leave this here in case you need to refer from step 1 until step 2. Give me 10 as that's fine.
We did not get this question. No, I did not get that.
All right, 1 more minute. Can I see a show of hand who is back? Jing Sam is back. Xuan Xuan, not yet. Eric, yes. Xuan, yes. Jaden, Kevin, Jovin is back. Jaden and Kevin still resting. Jaden is back. Kevin, are you back? Kevin, not back yet. Okay, time's up. Let's ask one more time. Kevin. Kevin, are you back? If you are back,
Yep.
can you show? Yep, you're back. Excellent. Okay, so now, I hope by now you also have the same feeling that your understanding level increased, right? Whether it's to the level of 4 or even higher. Some of you, I think, could be higher, right? But as long as you have a improvement from at about 8:30 to now about 1 hour, less than 1 hour, because we did not start at 8:30. We started 8:32 in step 1, and step 2, I think maybe about 8:40. So less than 1 hour, you should already have some understanding on this chapter. What is this chapter about? And what is each of the sub-chapter, which I name it drawer, about? Now, to solidify your understanding, before we move on to the story, step 5 is to read more, but more detail, right? So because that step 5 is to help you to go from 4 to 5. 5 is 50%. 50% is pass, right? So let's do this. It's a bit long. Okay, I'll divide them into 2 parts. And let's start. Wait, where's my timer? All right. So your reference is over here. And you need to read on the right side, on the left side, until here. Let's start 1 minute now. All right, 10 seconds. This is touching point number 1. Okay, let's continue. This part here. This touching point number 2 and 3. 2 and 3. Everyday example and centripetal force. Ten seconds. Okay, let's go to the last part here before we go to drawer 2. Right, let's start Now, this is the point number 4 actually. Centripetal is point number 3. Methodology of calculating the mass. Ten seconds. All right. By now, your drawer 1 should level up to level 5. All right. So let's do the same thing for drawer 2. Okay, we divide into 2 parts. Drawer 2 until here. 1 minute, start now. All right. Let's do the second part, the human body. Effect on human growth. Right, this part. Let's do 1 minute now. All right, time's up. So your level should increase by leveling up from 4 to 5 for drawer 2 now. Let's go to drawer 3. 5 is still not a high level. If you do not fully understand, that's fine. Right, you still are at level step 5 now, not step 10. So let's do 1 minute and 30 seconds. You can start now. That's fine. Yep, 1 minute and 30 seconds for drawer 3. All right. Drawer 3 is done. Now we're going into drawer 4. Okay, let's divide them into 2 parts. 1 minute for here. Yeah, let's do 1 minute. All right, let's continue the second part for also 1 minute. All right, whoever wants to read it again, you can read it. Ten seconds. All right, let's continue the last part, drawer 5, before we go to step 6. Let's do 1 minute here. I think drawer 5 is rather straightforward. Escape velocity. Let's do it now. Ten seconds. Okay, now your understanding level should be at the level of 5 now. Still not at the top, but definitely not as 1 hour ago at 0 or at 1. So let's move to step 6. All right, before we move to step 6, I want to refresh a bit, just in case you've forgotten the drawers that you have. We have 5 drawers. Right, and these 5 drawers are these 5 names, where it is being linked using this very short story, very silly and very illogical story, but it will help you to remember the story in the name of the drawer in sequence. The first drawer is Newton's law. Second is gravitational acceleration. Third is Kepler's. Fourth is satellites. 5 is escape velocity. I think by now, by just telling you drawer 1, Newton's law, without going into reading the step 3 or step 4 or step 5, you already have some idea what is this Newton law about, right? Newton law is about this centripetal force, the definition of Newton laws with this proportional to the mass and inversely proportional to the square of the distance, right? Then gravitational acceleration, what is it? What is inside gravitational accelerations? Right, is this the effect of human growth. That's point number 3. Then the variation of the G. Right, then Kepler's law is even easier. You have 3 laws. Man-made satellite, right? You have these points over here that you can explain. Escape velocity. What is escape velocity? I think by now you know, right? So step 6 is to help you to transform this into a story that you can remember this easier, right? So let's do one by one. Drawer number 1 is Newton law. What is this story? The story is a boyfriend and a girlfriend ran 2 kilometers away or apart, and then tie a centipede and spin it in a heavy orbit. All right, so what does it mean? I think this boyfriend and girlfriend, that means there are 2 planets, they are attracted to each other, which is this M1 and M2, and they ran 2 kilometers apart. Why 2 kilometers apart? Because there is this r square. There's a 2 here, r square. So this 2 kilometers is to represent the 2. Or 2 meters apart or 2 kilometers apart is up to you. Right, they are 2 kilometers apart. Right, so the boyfriend went into the west side and the girlfriend went into the east side. So 2 different opposite directions. Right, but they are attracted to each other because they are boyfriend and girlfriend. Right, then they tie the centipede. Centipede is a type of insect that is poisonous. It sounds a bit like centripetal, right? For me, it sounds a bit like centripetal, right? Then you spin, you tie it on a rope and you spin it, and it's moving like a heavy orbit, right? So this is to explain the orbit and the mass. Mass is heavy, so heavy orbit. Right, I hope this story is able to help you to remember some key points that is related to this drawer. This is my story. Right, I have to start somewhere so that you can see how this study method works. If you have your own story, when you are expert in building story, then by all means do it by yourself to build a story that is relevant to you, to be able to help you to remember the key points in this drawer. Right, the main objective of this story is just to help you to remember the key points in this drawer. Then drawer number 2, gravitational acceleration. Travel under and above Earth, became small lung and low blood pressure. Right, so this is to tell us that in the drawer there are informations that's related to below Earth and above Earth. Right, below Earth and above Earth. So you travel below Earth, or under the Earth, and above the Earth. And then your lung became smaller and your blood pressure became low. Right, because that is a human effect of the human body. Right, so this is this part here. Right, the story. If I translate that story into a picture, I'm not a good artist. That's why you see my drawing is like this. So I travel below the Earth. This is the Earth, and above the Earth. Then my lung became small, and my high blood pressure, and my blood pressure became low. Right, this is the girlfriend, and this is the boyfriend story. Then Kepler's law. Kepler's law, elliptic. Elliptic is a boy. His name is elliptic. Ran faster when nearer to sun, and ran 3 laps in 2 seconds. Right, so you can elliptic obviously is to reflect the Kepler's first law. Run faster nearer to the sun is to reflect the second law, and the 3 laps in 2 seconds is the third law. So this is how I draw it. Right, drawer number 4, Newton ran fast and free fall into Earth. Shout, I like geography. Right, so this is the picture. So how I relate this to the keywords, because you see the key messages is Newton, the experiment of the Newton, then the linear speed. Right, so Newton ran fast and then free fall. So free fall is to represent, the satellite is keep on free falling into the earth, but it doesn't fall. Then I shout, I like geography because to help us to remember that there are two types of satellite, geostationary and non-geo. So geography is, I use it to represent this geo, right? So escape velocity, whoever, I ran at high velocity to escape, and then I breathe air. So this is to explain the escape velocity. You have to run very fast, and then you are able to escape. Then you breathe air. The air is to represent the atmosphere. So all the air molecules that are being captured in the atmosphere, within the Earth, this is to represent that point there, right? So this is how I ran fast, up and horizontal, then I breathe air, right? So let's watch the YouTube to help you to remember the story.
Form 4, Chapter 3.
I think everyone can hear the video. You can watch and you can see the video and you can hear the video, right?
Gravitation. Newton, using strong
Can I have
gravity.
one show of hand that you can hear? Okay, right. So I'll start from zero again. I'll start from start. Okay, how this video is being designed is only 1 minute. The first part is the main story. Remember the Newton pulling Kelly into this lake, okay? Then it will be separated into different stories for different drawers. All right, so let's start now.
Form 4, Chapter 3. Gravitation. Newton, using strong gravity, pull Kelly into man-made lake. She'll escape. Draw 1. Newton law. BF and GF ran 2 kilometers away. Tie centipede and spin it in heavy orbit. Draw 2. Gravitational acceleration. Travel under and above Earth. Became small lung and low blood pressure. Draw 3. Kepler's law. Elliptic ran faster when nearer to Sun. Ran 3 laps in 2 seconds. Draw 4. Man-made satellites. Newton ran fast and free fall into Earth. I likes geography. Draw 5. Escape velocity. Ran at high velocity. To escape and breath air.
All right, so this is important for you to do your revision, the 10 minutes revision, right? To maintain you at level 9. Because if you are not doing the revision, your understanding, let's say you are at level 9 now, will over time will gradually decrease to level 7, 6, or even lower. Now, so I assume everyone's understanding of the drawer now should have another level up to level 6 now, right? Level 6 is a good level now for each of the drawer. Now let's see whether we are able to continue to bring it up one more level up to step 7, via step 7. So how do you do this? You read the questions, and then you ask, which drawer is this? Obviously, it is drawer 1, right? Which drawer or which sub-drawer is this? Then before you read the answer, you form a very rough answer in your mind, and then you compare with the answer. Right? Let's see if this help you to improve from 6 to 7. Let's do question number 1 in 1 minute now. For those who finish reading, you can read it again if you want. All right, I think it's a bit too long for 1 minute. I'm not sure. Let's do 1 minute for question number 2. It's also drawer number 1, but which part in drawer number 1? Okay, let's do it now. Yeah, I think it's too long for these short questions. Let's do 30 seconds enough, I think. All right. So you know now every object will have some forces, right? But it's too negligible compared to the forces that is pulling from the Earth, the gravitational force. So let's do 1 minute for drawer 2, these 2 questions. Let's start now. Okay, 10 more seconds to improve your level to level 7. Right? So let's do drawer 3, 1 minute to level up to 7. $30. You should be in second question now. All right. Drawer 4 leveled up to 7. Let's start now. Ten seconds. Right? Drawer 5 leveled up to 7. Let's do it now. 30 seconds. Ten seconds. All right. Okay, now it's the easiest part. Step 8 and 9 is the easiest part. We will have a video. Let's watch the video. How long is this video? 6 minutes.
Okay, let's talk about gravity. It's this invisible force that dictates
Can everyone hear and watch the video?
pretty much
Can I see one
everything,
show of hand?
from a
Okay,
single
Eric,
apple.
done. I think it's okay. Yes, all right. So 6 minutes. How do you watch this video, Kevin? Is you remember the 5 drawers. This video is being designed based on the 5 drawers in sequence. Right. So whenever it reaches the first drawer, you remember this is first drawer. And then you remember what are the key information inside the first drawer. If you can remember or you jot down the story, then that will help you to remember what is inside the first drawer, and so on and so forth. So until drawer number 5 in 6 minutes. So let's start now.
Talk about gravity. It's this invisible force that dictates pretty much everything, from a single apple falling from a tree to the grand dance of entire galaxies. Today, we're going to break down gravity, the true architect of our universe. So, let's get things off with a puzzle that people have thought about for, well, forever. Why does an apple fall down, straight to the ground, but the moon just kind of hangs up there in the sky? It seems like they're playing by two totally different sets of rules, right? But as you're about to see, it's all the same game. And the person who cracked this cosmic code was, you guessed it, Isaac Newton. He had this absolutely revolutionary idea. The force that pulls an apple to the ground is the very same force that holds the moon in its orbit around the Earth. Mind-blowing stuff. So how in the world did he make that connection?
Drawer 1.
Let's trace his thought process. We're going to start with that famous apple and zoom all the way out to the moon. Newton figured out that this force really just boils down to two key things. First, mass. The more stuff you pack into an object, the stronger its gravitational pull. Makes sense. Second, distance. Gravity gets weaker as you get farther away. But here's the kicker. It doesn't just get a little weaker, it drops off super fast. It's kind of like the light from a candle. The farther you are, the dimmer it gets, and it gets dimmer really, really quickly. And this is where the pure genius comes in. Newton took all of this and packed it into one single beautiful equation. This one formula doesn't just work for planets and moons. It describes the gravitational pull between any two objects in the entire universe. You and me, your phone, Jupiter, everything. That's why it's called the universal law. Okay, so that's the big
Drawer
cosmic
2.
law. But let's bring it right back down to Earth. How does this grand formula relate to something we all feel every single second of our lives? Our own weight. So here's the big connection. The force we call weight, which you probably learned in science class as mass times acceleration or F equals mg, that's just our local, everyday experience of Newton's universal law. They're two sides of the same coin. Your weight is literally just the gravitational force pulling you and the entire mass of planet Earth together. And since they're just two ways of talking about the same force, we can set the equations equal to each other. Now watch this. This is the cool part. The mass of the smaller object, you, an apple, whatever, is on both sides of the equation. So it just cancels out. This is amazing. It means if you ignore air resistance, a feather and a bowling ball will fall right, and with this one simple step, we can figure out g, the fundamental acceleration of gravity, for any planet out there. So, when you actually plug in the Earth's mass and its radius into that new formula, what do you get? You get this number right here, 9.81 meters per second squared. See, it's not just some random number they make you memorize in school. It's a direct result of our planet's size and mass, all figured out from a law that runs the entire cosmos. All right, now let's zoom back out.
Drawer
Because you
3,
can
Kepler's
see
law.
gravity acting like a sort of cosmic choreographer for the planets. And way before Newton came along, an astronomer named Johannes Kepler had already figured out the basic dance steps. So first, Kepler realized that planets don't travel in perfect circles. Their orbits are actually ellipses, squashed circles or ovals. And the sun isn't right in the middle. It's off to one side at what's called a focus point. Second, he noticed something really interesting about how fast the planets move. They speed up when they get closer to the sun and slow down when they're farther away. Think of it like this. To cover an equal-sized slice of pie of its orbit in the same amount of time, a planet has to move a lot faster when the slice is short and fat, and a lot slower when the slice is long and skinny. And third, he discovered this really elegant mathematical link between a planet's year, how long it takes to go around the sun, and its distance from the sun. To put simply, the farther out a planet is, the much, much longer its year is. Okay, so let's bring it back home and see how we've used all these cosmic rules to our advantage. I'm talking about the thousands of man-made satellites that are circling our planet as we speak. So how does the satellite stay up there without just falling back down? Well, here's a wild thought. It is constantly falling, but it's also moving sideways so incredibly fast that as it falls, the Earth curves away underneath it at the exact same rate. Gravity provides that constant inward tug that keeps bending its path into an orbit, instead of letting it just fly off in a straight line into space. Now, this creates an unbelievably delicate balance. For any specific altitude, there is one and only one perfect speed satellite in a nice, stable orbit. Go just a little too slow, and you'll spiral back down to Earth. Go a little too fast, and you'll break free from Earth's gravity and fly away forever. But what if flying away forever is exactly what you want to do? I mean, what if you don't want to just orbit? You want to leave for good. Well, for that, you have to break the chains of gravity. We're not talking about staying in an orbit anymore. This is about hitting a speed so fast that gravity can never ever pull you back. We're talking about escape velocity. And the number you have to hit, it's just staggering. To break free from Earth's gravity completely, you have to be going over 11 kilometers every single second. That's the barrier that every rocket has to break to send missions to the moon, Mars, and beyond. And as you can see here, this cosmic speed limit is totally different for every world because it's all tied to mass. It would actually be pretty easy to launch off the moon. But escaping the sun's monster gravity, that requires a speed that's almost impossible to even imagine. But Earth's high escape velocity isn't just about keeping us stuck here. It's the very reason we can live here at all. See, the air molecules in our atmosphere are all zipping around at about 500 meters per second, but that's nowhere near fast enough to escape Earth's powerful gravitational grip. Our gravity literally holds our atmosphere, our entire life support system, in place. So from one single falling apple, Newton's laws basically gave us the map to the heavens. They taught us how to stay here on our world and how to break free. Gravity is both the chain that binds us and the rails that can guide us to new worlds. Which leaves us with just one question. Where do we go next?
All right. I hope by now your understanding level increased to 8. Now, let's go to step 9, podcast. Podcast is also easy. Just listen. And what I will do, I will highlight.
If you want to, like, shoot a tiny pebble.
So it's only 5 minutes. I'll put on the reference step 2 over here. So whenever the podcast discuss on the points that are in this drawer, I will just highlight. And the podcast is also being designed in a way that is following drawer 1, 2, 3, 4 in sequence. Okay, so let's start from start.
If you want to, like, shoot a tiny pebble off the Earth, it actually takes the exact same speed as launching a massive 100-ton rocket. Both of them require you to hit 11,200 meters per second.
Yeah, which is super counterintuitive. But today's deep dive is going to explain exactly why that fact is true. We're basically taking the raw data from your physics notes and, extracting the real governing the cosmos.
Right, like how gravity dictates falling, orbiting, and eventually how to break free entirely. So let's jump straight into the universal pull of it all.
Good place to start.
The fundamental rule of Newton's universal law of gravitation is that literally any two objects with mass are pulling on each other. And I used to picture this as, I don't know, an invisible bungee cord.
Oh, right, sure.
But a bungee cord actually gets stronger the further you stretch it. Gravity does the exact opposite. It weakens drastically with distance.
Yeah, a much better way for you to visualize this is like a massive invisible funnel. Everything with mass creates a dip in the fabric of space.
Okay, a funnel.
Exactly. And the Earth creates a very deep, steep funnel. But the slope of that funnel, it flattens out exponentially the further away you get.
Because distance is baked right into the math. The higher you go up that funnel, the weaker the pull gets, which honestly drastically changes how we should think about gravitational acceleration, or G.
It really does. We all get taught that G is just 9.81 meters per second squared.
Like it's a permanent rule of the planet or something.
Right, but G actually drops the further you travel from Earth's center. The pull physically weakens as you gain altitude.
But if that's the case, if that slope is constantly pulling every single object down toward the center, how does anything stay up there? I mean, why doesn't a GPS satellite just slide down the funnel and crash into the ground?
Well, the crazy thing is, it actually is sliding down the funnel. Satellites are in a state of continuous free fall.
Wait, they're always falling.
Always. But they are moving sideways incredibly fast. They have so much horizontal velocity that as they fall downward, the spherical surface of the Earth literally just curves away beneath them.
Wow, so they are constantly falling and constantly just missing the ground.
Exactly. And that perfectly brings Kepler's laws of planetary motion to life, because orbits are elliptical, meaning they aren't perfect circles.
So the satellite essentially rolls deeper into the funnel, getting closer to the massive body it's orbiting.
Right, and as it gets closer, the pull is stronger, so it naturally speeds up. It basically whips around the planet before slingshotting back out to the shallower, slower part of the funnel.
Which creates a really delicate balance for man-made satellites. Gravity is providing the centripetal force holding them in that curve. You can't just, park a satellite in space and leave it there.
No, definitely not. To maintain a specific altitude, a satellite has to travel at a highly specific linear velocity. It ensures its rate of falling perfectly matches the curve of the Earth.
Okay, but what if you don't want to orbit? What if you want to leave that funnel entirely?
Then you have to inject enough kinetic energy, so energy of motion, to permanently overcome the gravitational potential energy holding you in the dip. You need to achieve escape velocity.
And this brings us back to the pebble and the 100-ton rocket. It intuitively feels like a heavier object should need way more speed to escape. Why doesn't the object's mass matter at all?
Because when you calculate the kinetic energy required to break a planet's gravitational grip, the object's own mass actually appears on both sides of the equation.
Oh, so mathematically, it completely cancels out.
Yep, you are purely fighting the mass of the planet pulling you back. The escape velocity is just a strict speed limit set by the Earth, regardless of what vehicle you're driving.
And that speed limit is 11,200 meters per second.
Which is the hidden mechanic keeping you alive right now. The air molecules we breathe are bouncing around randomly with an average linear speed of about 500 meters per second.
Not even close to what they need to escape.
Not even close. Earth's massive dip in the funnel requires too much kinetic energy to overcome. Those vital oxygen molecules simply do not have the speed to leave, so they remain trapped here on the surface with us.
So we've gone from everything pulling on everything to the slingshot of elliptical orbits to the exact speed limit required to break free. It's one beautifully continuous mechanical system.
It really is. It completely reframes the night sky once you see the rules holding it all together.
I'll leave you with this final thought. We just explored how Earth's massive size tunes our escape velocity high enough to trap our atmosphere.
Right, the funnel is too deep for the air to escape.
Exactly. But apply that exact same logic to Mars. It's much smaller, meaning its escape velocity is significantly lower. Over billions of years, a lot of its early atmosphere actually had enough kinetic energy to simply vibrate right off the planet and escape into the void. Makes you appreciate our heavy Earth just a little bit more.
All right. So by now, your level of understanding should be at the level of 9 or near to the level of 9. So let's see. Let's do a quick test to test if you are near to the level of 9 or you are still at 1. Right, I uploaded the textbook into the ChatGPT and asked 10 questions. Ask me 10 MCQ 1 by 1. Oh no, 2 by 2. 2 by 2 without answers. Right? So I'll put this at one side. Okay, you have two MCQ here, 1 and 2, and you have on your right side is the reference here. And I hope in front of you, you have the drawing or the stories to help you to remember what you have learned. So let's try. So Kevin, what we always do now is in the chat, you can type what is the answer. For example, let's say answer question A, 1 is A, and 2 is also A. Then you just type on the message.
Teacher, it doesn't
Right.
allow me to type on the chat.
You cannot type?
Yeah, I cannot type. It's disabled.
Okay, then you just if you're okay, then you just tell me what's your answer when you read the questions. All right, everyone can start now. Question 1 and question 2. What is the answer? You can type or you can tell me the answer. Drawer 1. Question 1 is drawer 1. Dim sum is A and B. Eric is B. Okay, let's see. Now we have two different answers. A or B. 2 is B. Waiting for Jaden, Xuan. Jing Sum asking for weight. Okay, let's see. C and B. Okay, no longer A. So let's see C and B. Eric is B and B. Okay, what about Jaden? Xuan is C and B, like Jing Sum. Okay, so we have two different answers for question 1. What about Jaden? Jaden and Kevin. Two objects are moved apart. What happened to the gravitational force between them?
C and B.
I cannot see the chat. I cannot type in the chat.
Okay, then you can just tell. Why you can't type in the chat? Some people, but it's okay. You can just tell me. You can just give a guess. Kevin also.
C, B.
Yeah, I said C and B.
You also C and B. Okay. So majority is C and B. Eric B and B. So we'll take the majority. Come on. This. Okay. So it's C and B. Right. So let's review the question again, Eric. Two objects are moved further apart. What happened to the gravitational force between them? It decreases with the square of the distance. Remember this formula? F equivalent to G M1, M2, and R squared. Yes. Okay. So there's new information for you, Eric, in your drawer 1. Now, drawer 3 and drawer 4. Let's start again. Okay, Jovin is back. Jovin, we are at the step 10, question 3 and question 4. I think you know the drill. You can type in and tell us what is the answer. Also, everyone is starting to give their answers. According to the Kepler's law, the orbit of a planet around the sun is? Okay, Xuan is B and C. Eric is also B. Jing Sam, Jovin, Jaden, Kevin. Jing Sam is also B and C. Jovin is also B and C. Okay, Jaden and Kevin, what do you think?
is C and C. I think.
C and C. All right, we
Oh,
have
no.
two different answers.
Yeah, B and C is okay.
B and C. Okay, B and C. Okay, then we have the same. Jaden, what about you?
B and
Yes, B and
B and C.
B and B.
B and C. B and C.
B and C. Okay, so everyone got B and C. I also think it's B and C. All right, so far so good. Let's do 5 and 6. All right, 5 is escape velocity, 6 is Newton law. It goes back to drawer 1. What is the main purpose of escape velocity? To keep the satellite in the orbit, to allow object to overcome gravity and not to return, to increase gravitational force, to reduce mass. If the mass of one object is double the other. So, B and C. Shen is B and C. Number 6, look at this formula, all right? Now I think you should be quite familiar with this formula now. It's not alien to you anymore. Number 5 is CN. Eric, CN.
B and C again. I think.
Kevin, B and C. Jovin. Okay, so we have number 5, 2 different answers. Jovin is also B and C. Jingsam. Jaden, what about you? Jingsam is
I think
B and
it's
C.
B and A.
B and A. Okay, we have this A. B and A. Right. So Eric is C, right? Okay. Okay, let's do the one that I think is wrong, okay? Because I'm also learning together with you, right? Explain if answer is wrong. Okay, I think C and A is wrong. Right, both are wrong. So why is it wrong? For the one who answers C, who is it? Eric. Okay, this is the answer. Okay. Number 6, who got it wrong? I think it's Jaden. Right. What is C? C is C is double, yes. So we answer what? You answer A, half. It's not half. Because if you double up either M1 or M2, that means the F is double up. So obviously, when you double up any mass, the force is also being double up. So the answer is double up. All right? So now we have 2 new informations. Jaden and Eric need to put it inside your respective drawers. All right, apart from that, let's continue 7 and 8. Okay, 7 is gravitational acceleration. This is here. So use the right formula. Okay, Shen is typing.
C and C, I think.
C and C. Kevin, C and C. Shen is B and C. You don't know why is always the same. Okay, I also do not know why. B and C. Okay. Oh, nobody puts B and C. B and C also. B and C, Jovin. Jaden, what about you?
B and C.
B and C. Okay, so only Kevin is C and C. I think it's B also. Why, Kevin? C, let's see. Stay the same. Okay. So if you look at this formula, what happened to the G if the mass is M, M increase, R same. So G will increase if M increase, right? So it will not stay the same. It will increase. So the answer is B and C. All right. Okay, let's hope it's no longer B and C. Okay, okay, now they explain. Even we got it correct, they explain to you. So you can have a quick look here, Kevin. Right, it's explaining the same explanation just now. Right? Okay, 9 and 10. Drawer 4 and drawer 5. Let's see. What happens if a satellite speed is too low? Okay, I think it's no longer B and C.
C and C.
C and C. Okay, let's try. Shen is also C and C.
Yeah, C and C.
Jaden, C and C, excellent. We have Jovin and Jovin left. Okay, Jingsam is also C and C. Jovin, C. Eric, same. Jovin, you put 1C, I assume is C and C. Okay, let's see. All right. Excellent. So overall, I think some got 10 out of 10, some got 9. Most of you got 9. Right. So that tells us what? At least for these very fundamental MCQ questions, most of you got 9 out of 10. Even if it is 8 out of 10, it's also considered a good results, because what time did we start? 8:32. Now it's not even 10:32, it's less than 2 hours. In less than 2 hours, all of you now is able to understand what this chapter is about, right? It doesn't mean that when you go for the exam tomorrow, you're going to get 90%, right? This is the first step. You have your fundamental right. You need to do revision, of course.
Yeah.
And also you need to do more past year questions to make yourself exam ready. Okay? Jaden, you have something to say?
No.
Jaden 错2题，很厉害了，错2题。这个是 year 10的，你是 year 8罢了。Okay? So I think it's a very good results for everyone. Okay? Thank you very much for coming. I hope you learned something today. Let's continue for next week. Let's see what chapter we want to engage and learn. Thank you, Jovin. Thank you, everyone. Bye-bye.
Thank you. Bye-bye.
Bye.
Bye.